All right, so yesterday we learned the sine law, and now we're on to the cosine law. So it's a little bit more complicated of a formula, but very similar kind of in solving triangles in the same way. So I started off with the proof this time. I'm not going to go through it line by line. If you'd like to see that, I can definitely show you how it works. But basically, if you split any triangle into two right angle triangles, like they've done here, you can use Pythagorean's theorem to prove that this cosine law works. But what I want to go over is just the labeling again. So if we forget about height and distance, we just want to emphasize again that we're using capital letters to represent the angles. So this is capital angle C, and it is always opposite small c, meaning the length of a side. So small letters, length of a side. Capital letters or big letters are the opposite angles. So we definitely have to know how we're being labeled. This is an angle symbol, not an L. So you definitely need to know how they're being angled for any of this to make sense. So if we did split it up into two triangles, we could use Pythagorean's theorem to prove that this is. But what all we really need to know, you can pause, you can read through this, you can have it make sense to you, or you can just believe me. This is the way it works out. And so this is the way it's written. If we're trying to find a side, and again, we're only using acute angles this year. We'll use obtuse angles next year, which get a little bit more complicated. Oops. Making sure the opposite angles and the opposite side have the same letter, but one's lowercase, one's uppercase. So today we are only finding a side using cosine law. So finding a side using cosine law. Man, I cannot write and speak at the same time. Finding a side using cosine law. So we end up with three different formulas, and really, the real one would be like that, because in order to find what A is, we need to square root both sides of that. So if we want to find A here, it looks more complicated, but if you think about it, it's not really that hard to remember because the opposite two sides are used twice. We have to square them both, and then we have to subtract 2 times the opposite side. So if you're trying to find A, it's A squared equals B squared plus C squared minus 2 times B times C, and then the opposite angle to the one we're trying to find. So this is A and this is A. So that's a way to remember it for our test at the end, is the one letter is going at both the beginning and the end, and the other 2 letters are used to be squared, adding together, then subtracting 2, and then those same 2 letters. So it's a lot longer formula than the sine law. It's a little harder to use. If we're solving a triangle, we usually use this to find one, and then use the other, or use sine law to find other ones. So you can derive similar equations for the other sides. Combining the results gives you 3 forms of the cosine law. So depending on which side we're trying to find, we need to have the other 2 sides and 1 angle. in order to find the third side. The third side. So we need to have a fair bit of information. So we needed to have, basically this is what we use when we only have one angle. Or we don't have two sides that work. So if we were going to use the sine law on this one, we would need to have either this angle to crisscross with this, or we'd need to have this angle to crisscross with that, or we'd need to have this side to crisscross with that angle. So we need to have opposites that work. We use the cosine law when we don't have opposites that work. When we've got two of one, in this case two sides and one angle, and then tomorrow we'll learn if we have two angles and one side, kind of working that way out. So sine law is easier. If you can use sine law, use sine law. When you don't have a pair that match and you can't find a pair that match, then it's time to use cosine law. So in this example, find a side length using cosine law. A boat is sailing north through a narrow strait. Through one particularly narrow section, a lighthouse marks the western shore, while the buoy indicates a rock hazard directly east of the lighthouse, as shown. What is the width of the section of the strait to the nearest tenth of a kilometer? So we need to know how much space do we have. Still on eraser. How much space do we have between the rock hazard and the lighthouse, given this information? So from the boat, we can see how far away we are from the lighthouse. We can see how far away or measure how far away we are from the rocks. And we know what degree that makes, but we need to know, do we have enough room to get through between the two of them? So really, the rock drawing should be like on the edge of that, and this drawing should be on the edge of that. The drawings are a little off. We want to know, can we fit our boat between those two things? So we need to know that strength. So if we label them, with A, B, and C, then we need to know which of the formulas we're going to use. So we want to find little a, and like I said, we take the other two squares, just like the Pythagorean theorem, adding them together. Then we minus 2, the two sides that we haven't used. Then cos of the capital of the one we're trying to find. So that is our formula. Then we're just filling in the blanks. A squared is what we're trying to find. B is 4.2, and it doesn't matter which one we labeled B, which one we labeled C, as long as the other two lines are being used like this, and the one we're trying to find is the one on the outside. And that is degrees. All right, so time for some fancy calculator work. And remember to use as many, at least 4, but as many decimal places as possible. The book just shows the answer, so I'd rather go. So A would equal the square root of 3.9155. It'd probably be okay to stop there, but you could continue further, would be a more accurate result. And then finding the square root of that. And again, we could probably put the approximate equal sign up as soon as we get there. Is 1.97878, and it keeps going on and on and on in there. And now it says that we wanted to know it to the nearest tenth of a kilometer. So now we round. Some people are still not reading that where do we want to have the answer to? Nearest tenth of a kilometer. So I would round it to there. But the thing is, if I round that, I'm looking at the 7. The 7 is going to round me up. So then I've got a 10, and so I go 2.0. So I'm still showing that 10th place, but because I had to round it, rounded the 9 to a 10, and then that 1 got added on to the other one. So make sure that we are rounding correctly. We wouldn't leave that at 1.9. And we wouldn't just put 2. We want to show that that is to the 10th of a decimal, so we put the 0 back in. And then, of course, we want a sentence. And then we would know whether or not we had enough room to sail our ship through. 2 kilometers is pretty big, so most ships are going to be able to sail through that. And that's it. So it is really just a matter of putting it through your calculator. And again, you can do this in little bits. I was just copying from the book, but I would have done that at one time, that at one time, that at one time. So I would have had 17.64, and again, try not to round on these unless you've got like if it says 17.64, don't put in 17.6. Once you start rounding, that's when you end up with things that are off. Minus, running out of room there. All right, so that's just a middle step in there before we get to that. And then once we do that final multiplication and then add and subtract, we're getting to here. So make sure that you can get all the way to this step. If you're having trouble with that, then message me about it. This is the version found in the textbook. Example 2, solving a triangle. So again, solving a triangle means we want to have the 3 angles. We want to know what the 3 angles are. We want to know what the 3 sides are. So finding all 6 pieces of that information. So this one isn't drawn for us. We need to draw it. An acute angle DEF, where D equals 4.1 centimeters, F equals 6.2 centimeters, and angle E equals 64 degrees. Solve triangle DEF. Round measurements to the nearest degree, or 1/10 of a centimeter. So when we're doing lengths, we want 1/10 of a centimeter. When we're doing angles, we want it to be in nearest degree. So make sure you're following that when you're asked for it. So I have no idea what this triangle is going to look like, but I'm going to just draw a simple diagram. I know it's going to be called DEF. I know that little d equals 4.9 centimeters. I know that little f equals 6.2 centimeters. And I know angle E is 64 degrees. So again, not drawing it to scale, just doing a diagram so that I can mentally figure it out. So I need to find first what little e is. Once I have, Once I have little e, then I can use sine law. And sine law is a lot easier, faster, and less able to create problems by putting things wrong into calculators. So I want to find the other length first so that I have a pairing to use sine law. So e squared equals my other lengths added together, squared, minus 2, both the other sides again, and then cosine of the big angle opposite what I'm trying to find. So e squared equals 6.2 squared plus 4.9 squared minus 2 times the cosine of 64. And some calculators you need to put double brackets in there. So if I do all of that math, and again, this is math that should be, I'm not going to do all the steps because we should be able to do that. We end up with a square root of, approximately the square root of, because again, we need to round. Again, use at least 4 digits to try and make that as accurate as possible. And we end up with approximately 5.9845. And again, we've been asked to round to the nearest tenth of a centimeter. So again, we're going to end up with the same issue where as we round it, the 8's going to pop up the 9 to a 10, and we end up with approximately 6.0 centimeters. So it's very nice if you make a little box for me and put all of your answers. So we also need to find angle D and angle F. So because there's a lot of work in these ones and it tends to get messy, it's nice if you build that up for me. Did I leave myself another page? No, I did not. Oops. Come on, stay on the right page. There we go. All right, so yeah, switch of color. So now I have E equals 6.0. So now I've got a pairing back and forth. And now I can use sine law. So if I want to find angle D, I'm going to go sine D over little d equals sine E over little e. Fill in everything I've got there. I'm still trying to find what D is. I've got a 4.9 as my little d, sine of 64 over 6. Sine of D equals, we times both those sides by 4.9 to get it onto that other side, which equals approximately there, which means that our angle of D is the inverse sine of all of that, and then that is 47.224. Oh, crap. I had to be right at the end of a question, too. Yeah, we've been crashing a lot. Solving the triangle, so we had... Ooh, got my sparkly pen out. We had D equals 4.9. I had E on this side. We figured out E equals 6. And F. All right, so we were almost finished D, and we just figured out that it was 47.22, so it ends up being 47 degrees. So then we need to find angle, what are we missing? Angle E. Nope, angle F. Sorry. Is our last one. So again, because we're trying to find the angle, put the angle back up on top. When we're using sine law, put whatever you're trying to find in the top left position. It's the easiest way to work on it. Again, we want to come back to, we could use it using F or we could use it using E, but it's best to go back as far as possible because with all of your information relies on each other, and then you make a mistake, you're going to continue to make mistakes in the next section. So always go back as far as you can with using information to help you out. So F is 6.2. Or we could, at this point, just use our fact that our calculator, or fact that we've got two angles of a triangle and we can minus to calculate the third one. We can use that to check our answers at the end. So sine of 64 over top of 6. Actually, let's go a little step further. Inverse sine, just doing it all in one step. We end up with F equaling 69. And we can check that all up by going 69 plus 64 plus 42 equals, 47 equals 180. So please make me a little box with all of your answers in it. You can either put all 6 of them or just the ones we're trying to find at the end so that we have that. Sorry about the freezing of the iPad. Answer from the textbook. So again, in order to find that last one, we could have just used subtraction all along, but it's better to use both and then make sure that you're correct. And that's it for today. So key concepts. Again, the labeling, same letters crisscrossed. In an acute triangle, again, we're only looking at acute triangles, which means A, B, and C. All 3 of those angles are less than 90 degrees. Once we get greater than 90 degrees, we have to use a little bit more information. In an acute triangle ABC, the cosine law states that we can write it in 3 different ways depending on which side we want, but if we want to find a side, we need to square that side equals the sum of the squares of the other 2 sides minus 2 times, again, the other 2 sides, and the cos of the opposite angle. Cosine law can be used to find a missing side if the other 2 sides and their contained angles are known. So we need to have, basically we need to have all of that information that's in that sign. So we need to know the other 2 sides, B and C, and we need to know the opposite angle. And there's a homework for today. Please look, or for this section, please look at the Google Classroom post for practice questions that will be due tonight.